Good afternoon, my viewers and all the people in the internet. It might be morning or evening in your place, and if you are in such areas, I also greet you. Today, we deviate a bit from the travel blogs and look at a tutorial in mathematics. And today I'm taking you through a topic which you really like. Remember, these topics I give you are initiated by my viewers. And then they tell me, Marim, can you come up with this topic and give us a video on that? So today, I'm dealing with the sequences and the series. In everyday life, we constantly meet patterns. Whether it's whether it's the way savings grow, all right, the steps in a staircase have a pattern, the arrangement of seats in a hall, or even the pattern of leaves on a plant. Just watch. There is a pattern. Mathematics helps us understand these patterns through sequences and series. In fact, a sequence is simply a list of numbers arranged in a specific order and formed following a clear rule or pattern. While a series, on the other hand, is what we get when we add the terms of a sequence. Understanding sequences and series helps us, 1. Predict future values, 2. Calculate totals quickly, 3. Understand growth and decay, and 4. Solve real-life problems in finance, construction, science, and even business. In this topic, you learn how to identify different types of sequences, how to find the rule of a sequence, how to calculate any term, how to find the sum of terms in the arithmetic and geometric sequences, and how these concepts apply in real life. By the end of this lesson, you will be able to recognize patterns with confidence and solve problems involving sequences and series with ease. Let's now go to the details of my topic, and I will start with the sequence, and this is the definition. A sequence is an ordered list of numbers arranged according to a specific rule or pattern. That is, numbers that follow a certain rule or pattern. Each number in the list is called a term. For example, in the sequence 2, 4, 6, 8, 10, and so on, 2, 4, 6, 8, and 10 are terms of the sequence. The position of a term is usually denoted by n, first term, second term, etc. Example, 2, 4, 6, 8, 10, and so on. This is a sequence where each term increases by 2. The first term, A1, is equal to 2. The second term, A2, is equal to 4. And the general term, AN, is equal to 2n. This is an arithmetic sequence where each term increases by 2. Sequences can be finite, that is, limited number of terms, or infinite, continuous endlessly. where an is the nth term of the sequence. A series is the terms of a sequence. A series I beg your pardon. I'm now in series. And this is the definition. A series is the sum of the terms of a sequence. For example, if the sequence is 2, 4, 6, 8, and 10, and so on, the series will be 2 plus 4 plus 6 plus 10 plus 8 plus 10 plus and so on. Finite series has a fixed number of terms. Infinite series continues without end. In short, series and sequences have the terms finite and infinite. Let's summarize the definitions and say a sequence is an ordered list of numbers following a rule, and a series the sum of the terms of the sequence. Difference between a sequence and a series. A sequence is simply an ordered list of numbers following a certain rule, e.g., 2, 4, 6, 8, 10. Here, we are just listing the numbers. So the key word is list. And you think of numbers arranged in a pattern. A series, on the other hand, is what you get when you add the terms of a sequence. For example, in the terms up there, we have 2 plus 4 plus 6 plus 8 plus 10 plus and so forth. Here, we are adding the numbers of the sequence. So the key word here is the sum. And you think of adding the terms together. Summary. Concept, meaning, and example. Sequence, meaning, list of numbers in order. Example, 3, 6, 9, 12. Series, sum of terms of a sequence, 3 plus 6 plus 9 plus 12 plus, so on. And the easiest way to remember is sequence, list, series, sum. Now let's go into details. And if you are watching this video and you are a student or somebody interested in sequences and series, you can now take your notebook. We go to the details. So I will first just remind you the definition of a sequence. And a sequence is an ordered list of numbers that follow a specific pattern or rule. For example, 2, 5, 8, 11, and 14, and so on. Number 2, types of sequences. We have arithmetic sequence, abbreviated AP. And this is a sequence where the difference between consecutive terms is constant. And the key features of an arithmetic sequence is the common difference, D, and D is given by subtracting consecutive terms. That is A2 minus A1. In arithmetic sequence, terms increase or decrease steadily. For example, 4, 7, 10, 13, 16. Here, the common difference is 3. All right? And in arithmetic sequence, we have the nth term, how you can get any term. So the formula is Tn is equal to A plus n minus 1d, where n is the term you want, that is first term, second term, third term, and A is the first term, all right? Of course, n I've told you is the term you want, and d is the common difference. B is geometric sequence, which is abbreviated GP. This is a sequence where every term is obtained by multiplying the previous term by a constant ratio. And the key features of a GP are common ratio, which is got by dividing consecutive terms. That you divide, if you have first term and the second term, you divide the second term by the first term. And it is abbreviated R, common ratio. For example, in 3, 6, 12, 24, and 48, and so on, the common ratio is 3 divided by 6, which is 2. You can also say 12 divided by 6, or 24 divided by 12, or 48 divided by 24, and the answer will always be 2. So the common ratio here is 2. Now, to get any term, or the nth term of a GP, the formula is Tn is equal to A r raised to n minus 1, where n is the term you want, A is the first term, and r is the common ratio. If you use that formula, you get any term in the GP. Important terms in sequences. A, first term, represented by A. Remember, this is just a convention. You can use any letter, but we use A in sequences. The starting number of a sequence. For example, in 5, 9, 13, 17, the first term A is equal to 5. B, common difference, or D, used only in arithmetic sequences. For example, in 5, 9, 13, 17, D is equal to 9 minus 5, which is 4. In fact, D is given always by the difference between two consecutive terms. Common difference are used only in geometrical sequences, and it is given by R is equal to A over A1, A2 over A1, where these are consecutive terms. For example, in 3, 6, 12, 24, 48, R is equal to 6 over 3, which is 2. The nth term, or general term, this is a formula that gives the value of any term in a sequence. In AP, the formula is Tn is equal to A plus n minus 1d, and in GP, Tn equals A r raised to n minus 1. How to identify the types of a sequence? Step 1, check the differences. If the differences are constant, then it is an arithmetic sequence. Step 2, check the ratios. If the ratios are constant, then it is a geometrical sequence. Geometric sequence, not geometrical. Step 3, check second differences. Example, 2, 6, 12, 30, 20, 30, and so on. First differences are not constant. That is 4, 6, 8, and 10, not constant. But the second differences are constant. That is 2, 2, 2. So this one is known as a quadratic sequence. If none of the above fit, it may be a special sequence known as Fibonacci, where each term is the sum of the previous two terms. Example, 1, 1, 2, 3, 5, 8, and 13. All right, each term is the sum of the previous two terms. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, and 5 plus 8 is 13. That is Fibonacci sequence. For our case, we are going just to deal with the two, that is arithmetic sequence and geometric sequence. Others you know when you can proceed with the mathematics. Worked examples. Example 1. Identify the sequence. So A, 10, 7, 4, 1. Check the differences and you find that the difference is negative 3. So the sequence is an arithmetic sequence with a common difference equals minus 3. B, 3, 9, 27, 81. The common ratio is 3. It is a geometrical sequence with common ratio R is equal to 3. Example 2. Find the eighth term of an arithmetic sequence. In fact, P means progression. So sequence 2, 5, 8, 11, and A is equal to 2 and D is equal to 3. Therefore, the eighth term using the formula is 2 plus 8 minus 1 times 3, which gives you 23. Example 3. Find the sixth term of the GP 3, 9, 27, 81. Here, the first term A is 3, and the common ratio is 3. And therefore, using the formula, the sixth term is equal to 3 times 3 raised to 6 minus 1, which is 5, which is equal to 729. Real-life applications of sequences. Number 1, monthly savings is an AP. Example. A student saves 500 in January, then increases the amount by 200 every month. So the sequence will be 500, 700, 900, 1100, and 1300, and so on. The common difference here is positive 200. Therefore, this is an AP because the increase is constant. Number 2 is salary increments. A teacher earns 40,000 shillings this year. Their salary increases by 3,000 each year. The sequence will be 40,000 to 43,000 to 46,000 to 49,000 to 52,000. The common difference D here is positive 3,000, and therefore it is an AP because salary rises by the same amount each year. Number 3, population growth. A, Population growth concerning people. A town has 10,000 people and the population grows by 5% every year. The sequence is 10,000. Next one will be 10,500. The next one will be 11,025. The next one will be 11,575.25, although you don't have a 0.25 of a person. And the common ratio here is 1.05. It is a GP because it grows by the same percentage. B, population growth, bacteria. A bacteria culture starts with 500 bacteria. Remember, these are very dangerous to our health. Every hour, the bacteria doubles in number. I'm saying they are dangerous, but some are useful because we have bacteria in our stomachs. The sequence is 500, 1,000, 2,000, 4,000, and 8,000. Common ratio here is 2 because the population doubles every hour. If you have one bacteria, after 1 hour, you have 2. After 1 hour, that bacteria divides into 2. The second hour, each of these 2 bacteria will divide into 2. So this is a geometric progression because the number increases by the same multiplication factor each hour. We continue with the real-life examples. We come to radioactive decay. A radioactive substance has a half-life of 10 years. Half-life means the time it takes for it to decay half of its quantity. This means its amount reduces by half every 10 years. So suppose you start with 18 grams, the sequence will be 18 grams, 14 grams, 20 grams, 10 grams, 5 grams, and so forth. So here the common ratio is a half or 0.5 because the amount becomes half after each equal time interval. This is a GP because the quantity decreases by the same ratio each time. GP is geometrical sequence, or sometimes you call a sequence a progression. Number 4, in real life interest rates. You invest 20,000 in a savings account earning 10% compound interest per year. The sequence will be 20,000, 22,000, 24,200, and 26,620. And the common ratio here is 1.10. It's a GP because interest is compounded, percentage-based growth. And then finally, YouTube channel growth. Like my YouTube channel. A channel starts with 1,000 subscribers and grows by 20% monthly. The sequence: 1,000, 1,200, 1,440, 1,728, and so forth. The common ratio here is 1.20, and it is a GP because the growth is proportional each month. So may I close by saying, my friends, that brings us to the end of our journey into sequences and series. We have seen how patterns aren't just numbers on paper. They are in our savings, in school timetables, in growth patterns, and even in how we plan our daily routines. If you can spot the pattern, you can solve the problem. If you can write the rule, the maths becomes easy. So keep practicing, keep observing, and don't forget Mathematics is simply the language of patterns, and you are getting better at speaking it every day. Thanks for running with me, and I will see you in my next lesson. I wish to sincerely acknowledge everyone who contributed to the preparation of this sequence and series tutorial. Special appreciation goes to Kenya Institute of Curriculum Development, KICD, for providing the syllabus guidelines that shaped the scope and the depth of this lesson. Kenya mathematics teachers and subject panels whose dedication and classroom experience continue to inspire quality content for learners. Students and learners across the country, your curiosity, questions, and desire to understand mathematics make this work meaningful. And finally, fellow educators and content creators who continue to share insights, examples, and best practices in teaching of mathematics. A heartfelt thank you to everyone who believes in the power of education. Your support ensures that students have access to clear, engaging, and well-structured learning materials. So, and by the way, I will give you an assignment, and it is a question which is going to earn you 8 marks. And this question is, a radioactive substance has a half-life of 5 years. A sample initially has 160 grams of the substance. Part A. Find the mass of the substance remaining after 15 years. B. After how many years will the mass be 10 grams? C. State a formula for the mass m after t years. So guys, do that question to see whether you have understood. Try first of all to identify what type of a sequence is it, so that you use the formulas which you have already been given. So don't look at this working, because of course you'll be interacting with my video. I've decided to give the answer and working, but do the question before you look at this working. So the formula, if half-life is equal to t half and initial mass is m0, the mass after t years is given by m equals mo, or initial mass, times a half raised to t, small t, over the half-life. For this question, initial mass, mo, is equal to m0 is equal to 160 grams, and the half-life, t half, is equal to 5 years. You get 1 mark for stating formula. All right. But you see, A, mass after 15 years, use m is equal to 160 times a half raised to t over 5, with the t is equal to 15. M is equal to 160 times a half raised to 15 over 5, which is 160 times 1 over a half raised to 3, that is 15 divided by 5 is 3, which is equal to 160 times 1 over 8, because 1 over half cubed is 1 over 8, and the answer simplifies to 20 grams. So the answer is 20 grams, 3 marks for substitution, evaluation of exponent, and final value. B, time for mass to be 10 grams. Solve 160 over 1 times a half raised to t over 5, because the half-life is 5, is equal to 10. You want to remain with 10 grams. So dividing both sides by 160, you get 1 half raised to t over 5 is equal to 10 over 160, which simplifies to 1 over 16. If you simplify 1 over 16 in terms of bases, you get a half raised to 4. Hence, a half raised to t over 5 is equal to a half raised to 4, which implies t over 5 is equal to 4 because the bases are same, so we equate the indices. And therefore, t is equal to 5 times 4 by cross multiplication, which is equal to 20 years. Answer, 20 years, where you get 4 marks. The first mark is for correct setup. The next one is simplification. The next one is equating exponents. And then finally, you get the final answer. So, summary of answers. A is 20 grams. B is 20 years. And the formula is m is equal to 160 times a half raised to t